Hey guys, it's Dan, and in this video, we're going to talk about the basics of functional programming in Python. So this video is going to be part of a series where I'm going to cover some of the basics of functional programming. So we're going to talk about immutable data structures and how you would typically represent your data if you're using a more functional programming style. And very importantly, we're also going to talk about what this functional programming stuff is anyway, and what that term means. In the course of these tutorials, I'm going to take you through a few examples where you'll learn how to work with the filter, map, and the reduce functions in Python. So these are some of the core building blocks of a more functional programming style. And it's generally a good thing to know about these, right? Like if you're wondering, okay, why should I watch this video? It's potentially a mind-expanding exercise for you where you can learn about a different programming style. It's not necessarily better than other programming styles like object-oriented programming or procedural programming, but it's another tool in your toolbox that you should really know about. So why don't we jump in here? All right, so in this first part of the tutorial, I want to talk a little bit about what functional programming is. And then we're also going to talk about how we can represent different data sets using a functional programming style, using immutable data structures, and why that would be a good idea and the benefits you can get from that. So functional programming, what is that? Well, it's a programming technique that avoids side effects in your programs by performing computation mainly through the evaluation of functions. And it'll rely heavily on immutable data structures as well. So I know that was a mouthful, and I hope in the course of this tutorial, things will become a little bit more clear. But basically, functional programming is a programming style, just like object-oriented programming, that has the potential benefit that it can reduce the likelihood of bugs in your programs, and it can potentially make them more maintainable as a result. So admittedly, the whole concept is a little bit difficult to pin down because when we talk about functional programming languages, a lot of times, a modern functional programming language would maybe be Haskell, and it's a little bit hard to pin down what really makes a programming language functional or not, or a coding style functional or not, versus some of these additional features that these modern functional programming languages support. So the definition I'm going to stick to in these tutorials is that, well, functional programming is a programming paradigm or a style of programming where we mainly use immutable data structures and we try to avoid side effects by doing all of our computation using the evaluation of mathematical functions. And that's based on the definition that Wikipedia uses, which I think is pretty general. And I think that's good because it leaves out all of the extra stuff that you would maybe think is part of functional programming, like the advanced typing systems in languages like Haskell. So just to give you an idea of what we're going to be focusing on in these tutorials. If you feel like, well, what's this guy talking about? I need to see some code, then we're going to get to that in a minute, because really, I think this is the best way to learn this stuff anyway. It's usually not much help to just, try and understand these concepts from an abstract perspective just by reading about them, but you need some stuff to play with. At least that's how I learn these things. I always want something that I can engage with and that I can work with. All right, so to illustrate some of these concepts and to teach you about some of the core functional programming principles and how you can apply them with Python, I was thinking of a little data set that I wanted to use. And so the data set I want to use in these examples is this list here of scientists that worked in different fields. They all have a name. You can see here, Ada Lovelace, Emmy Noether. They worked in different fields, math, physics. All right, physics, right? They were born in different years, and in some of them, they won Nobel Prizes. So it's just a simple list here with some interesting properties that we can work with, just so we have something, some data set that we can look at and that we can then work with in a functional programming style. Well, I have this beautiful table here. It's actually a markdown syntax, so this would render nicely if I wasn't viewing it inside my editor. But of course, the question is, okay, I have this list of things. This is maybe something that I extracted somewhere. Somebody typed that into an Excel sheet for me. How do I get this into my Python program? And how do I represent this exact same data inside my Python program? So this is what we're going to focus on next. When I started thinking about this tutorial, my first hunch was, okay, if I want to bring this into Python, I probably have a list of dictionaries. So I could say, okay, scientists equals, and then I would just have a list of dictionary objects, probably indent that, and I would put different keys like name, and I would put the respective field for the person, and I would put the year they were born, and then I would have some kind of flag that tells me whether or not they won the Nobel Prize. I would do something like that, right? And then just have a list of those. And you can imagine there would be some more here. So let me just copy and paste that. It's a little bit quicker. So there'll be more data here. And then eventually we'd close that list. And now we have this data inside Python and we can work with that. So this looks kind of nice, right? We have individual items here. They're represented by dictionaries, which is kind of neat. The only thing that I don't really like about this is that we've got a mutable data structure here. So we have a list of these dictionaries. And by mutable, I mean that I can just reach in here and I can say, okay, I'm going to grab the first scientist here. I'm just going to reach inside this data structure and I'm going to rename Ada. Give her a different name, right? And now, when I print this out, we actually modified the name of the scientist and it kind of screws up the data. In the beginning, I said, one of the core tenets of functional programming is actually that you mainly work, or ideally always work, with immutable data structure. So you want a data structure that can't be modified that way, because if you represent your data using immutable data structures, that has some really interesting properties. For example, if you wanted to have a multi-threaded program, you wanted to do some parallel processing there, you wouldn't have to worry about locking the data structure because there was no way to update it. All of these reads can happen in parallel, and we'd never have to worry about changing the state of this data structure while another thread is accessing it. So that would be one advantage of not allowing mutability here. And what it leads to, if you use immutable data structures that cannot be modified like this. So this example here, this was a mutable data structure that I could modify at will, at any time. With an immutable data structure, I couldn't do that. And that a lot of times leads to a cleaner conceptual model. I'm forced to do my calculations in a different way. And it's very easy also to come up with a history of the calculations that I do, because I can't just reach in and modify this existing object. But instead, what I'd have to do, I'd have to create a full copy of this data structure that I can modify. And so now there exist two copies that I can use in some kind of history, and I could trace back, I made these changes here. And of course, all of that, takes up more memory, at least if you do it in Python. In other programming languages, they have better immutable data structures. But the gist of it is that in a more functional programming style, you're trying to go after immutable data structures and then make them like the core parts of your program. Now, the other thing that I didn't quite like about using dictionaries here for this functional programming example is that, as you can see, I'm repeating a lot of the key names here. And that isn't perfect because what if I make a typo, right? What if I have a typo here? Instead of calling this field name, I call it name. And I would, just introduce a typo here. And in all the other fields, maybe they're okay and I didn't do anything wrong here. And I would define another item, but I just made this typo. There's no validation. I can just do that, right? I can just create this object here. There's no one double checking my typing. And I could just add that to this list. And there would be no guarantees that every item on this list would have the same properties. So that's why I decided to go down a different route. So what we'll do instead is we're going to import the collections module. And then we're going to define a scientist object, or I guess it's a class, using the collections named tuple function. So here we're going to give this thing a name. So this is going to be part of the doc string and it's going to be the type name. So you just want to duplicate that here just by convention because, this namedtuple function can't actually access the name you gave to the return value here. So we just need to duplicate this thing here. And then we're going to define a list of properties. And so here I would say, okay, we need a name. We need the field. We need the birth date. And we need a flag for whether or not that person won the Nobel Prize. And then we can close that function call. So this is a factory function that will create a new namedtuple class. And now we have this thing here called scientist. And it has a bunch of fields on it. And you can see here, these are exactly the fields that we were looking for earlier. And now I can create new scientist instances. So here I can say name equals Ada Lovelace. I can say field equals, and you can already tell here that these are not just dictionary keys, but these are actually keyword arguments that I'm passing to this function. So I can't really type and talk at the same time, but bear with me. So I'm assigning these to the values I want here. Now we're going to create our first scientist object. Right. So you can see here, this sort of kind of prints like one of these dictionary objects, but now it's a real scientist object. So we can say Ada equals the scientist object, and then we can access the field. So we can reach in here, we can say Ada.name, Ada.field, and so on. And the great thing is a named tuple instance is actually immutable. So I cannot go in now and say, hey, we're going to rename Ada to Ed. It doesn't work like that. You can't set an attribute on a named tuple. So now that means we have a way to represent these individual items and to represent this data set in an immutable data structure. So let's do that. So what I'm going to do here is I'm going to say scientists equals and then a list. And some of you might be going, well, why is he using a list here? We can talk about that in a minute. Because now, so far, we solved one part of the problem, right? So I have defined the scientists list here. And you can see here it prints kind of nicely. We can improve that a little bit with the pprint module. So I'm going to import pprint module. And then that is like a pretty printing module. It just gives us the better aligned items here, so that's a little bit easier to read. Okay, so now we've got the scientists list. And while I can't really go in and say, do this what I did earlier, I guess now I have to restructure it a little bit because now this isn't a key, it's actually a field. I can't do that anymore. But what I can still do is I can do this and delete the first scientist, right? And now poor Amy is all by herself. And that's a problem because when you look at what I did there, well, I was trying to define this immutable data structure. But what I actually did is I defined these immutable items and then stored them all in a list, which is a mutable data structure in Python. So I think the best way to handle this is instead of making a list, we're going to create a tuple because a tuple is a immutable data structure in Python. It's basically like an immutable list. So you can't add items to it or you can't remove items to it. And the way I would represent this data set is sort of like this. So now when you look at scientists here, okay, that look kind of good. That look pretty good. And if we pprint it out, then it also formats really well. And what I have now is I have a tuple of scientist objects. Previously, I had a list of dictionary objects. And so now we've solved this immutability problem, I think, because now with this list of scientists I have now, I cannot go in there. I can't delete anything. I can't modify this list, right? I can't add new stuff to it. I can't do it, right? But I can still access everything by index here. And that's pretty great. So this would be an example of a immutable data structure. This whole thing here, like that would be an immutable array of these scientist objects that are immutable themselves. So the whole thing is immutable. And this is, in a perfect world, this is where you want to be if you're doing any kind of functional programming in Python. You want to start with a solid data structure that ideally is immutable. I mean, you're going to see in the examples that we'll work through in the following videos that you could totally do the same thing with dictionaries that are mutable or lists. But I think there's a big benefit for thinking about how you can keep your data structures immutable if you're trying to work with a functional programming style. And I hope you can start to see why this is useful. It's going to become more obvious as we work through the other examples, but this is kind of the lead in to the other things that we're going to cover next. So what we're going to look at next is a couple of functional programming primitives like the filter function, the map function, and the reduce function, and how those correspond to some other things that are actually built into Python, like list comprehensions. And so this won't be like a full-on, oh, this is how you should all of your programs from now on in Python, but it'll more be like a fun dive into functional programming so you can get some inspiration and maybe see how you can apply that style in your own programs. All right, I'll see you there. Happy Pythoning.